MS Ramaya University of Applied Sciences.
Hi students, let us discuss the measurement of Planck's constant with LEDs. First, let me discuss the importance of Planck's constant. While trying to explain the shape of a black body spectrum, Planck assumes energy radiated cannot have all possible values, but some discrete values which consist of tiny bundles of energy later known as photons, each having a well-defined quantum of energy. Let me introduce to the light-emitting diode. A light-emitting diode is a forward-biased PN diode. A diode is a two-terminal electronic device which offers low resistance to the flow of current in one direction while high resistance in the opposite direction. Unlike conductor, the charge carriers here are holes in the p region and electrons in the n region. A hole is just like an electron with positive charge. In light-emitting diode, the PN diode is forward biased with P region connected to the positive end of the battery and N region to the negative end. In the forward biased condition, electrons from N region is pushed to the P region, where they recombine with the holes and emit light. By applying threshold voltage, which corresponds to barrier voltage, LEDs can be made to glow, which emits photons of certain wavelength. By measuring the threshold voltages across the different LEDs and knowing the wavelengths of the emitted light, one can plot a graph of wavelength versus inverse of voltage. From the slope of the graph, Planck's constant can be determined.
Welcome students. In this experiment, we will calculate the value of Planck's constant using LED. So, the apparatus required are the Planck's constant experimental setup, LEDs and connection wires. So, this is the Planck's constant experimental setup. It contains a source which has to be connected across the circuit. This is the voltmeter which shows the voltage across the light emitting diode, and we have to place the light LED here. Now, we will start the experiment. Before that, we have to complete the circuit. The circuit is completed as follows. Connect the source at these 2 points. Now, connect the LED in forward bias. In this experiment, we will be using LEDs of red, blue, green, yellow and IR wavelengths. In this experiment, we measure the new voltage for each LED. We will begin the experiment. First of all, switch on the source and switch on the apparatus. Now, take any one of the LED and place it in the LED socket. Now, the LED glows blue. Note down the corresponding wavelength from the table given here, and also note down the knee voltage from the voltmeter. Now, remove this LED and replace the next LED. Now, the LED glows yellow. So, note down the corresponding reading of the wavelength from this table, and also note down the knee voltage from the voltmeter reading. Now, repeat the knee voltage measurement for all the given LEDs. Now, from the obtained values of the knee voltages, the Planck's constant can be calculated using the formula, and also by plotting a graph of lambda versus 1 by V.
At MSR UAS, we spark your imagination unlike any other.